So the next topic is shared and exclusive locks. A read lock is also called as a shared lock and write lock is called an exclusive lock. These locks can be imposed on a whole file or a portion of it. This lock can be imposed on a whole file or a portion of it. A write lock prevents other processes from setting any overlapping read or write locks on the locked region of the file. The intention is to prevent other processes from both reading and writing the locked region while a process is modifying the region. A write lock prevents other processes from setting any overlapping read or write locks on the locked region of the file. The intention is to prevent other processes from both reading and writing the locked region while a process is modifying the region. A read lock allows processes to set the overlapping read locks but not write locks. A read lock allows processes to set the overlapping read locks but not write locks. Other processes are allowed to lock and read data from the locked region. Other processes are allowed to lock and read data from the locked regions. A mandatory locks can cause problems. If a runway process sets a mandatory exclusive lock on a file and never unlocks it, no other process can access the locked region of the file until the runway process is killed or a system is rebooted. A mandatory locks can cause problems. If a runway process sets a mandatory exclusive lock on a file and never unlocks it, no other process can access the locked region of the file until the runway process is killed and the system is rebooted. If a file lock is not mandatory, it is advisory. An advisory lock is not enforced by kernel at the system call level. It is not enforced by the kernel at the system call level. The following procedure is to be followed. Try to set a lock at the region to be accessed. If this fails, a process can either wait for the lock request to become successful or go do something else and try to lock the file again. Try to set a lock at the region to be accessed. If this fails, a process can either wait for the lock request to become successful or go do something else and try to lock the file again. After a lock is acquired successfully, read or write the locked region. After the lock is acquired successfully, read or write the locked region. Then release the lock. Advisory locks. A process should always release any lock that it imposes on a file as soon as it is done. A process should always release any lock that it imposes on a file as soon as it is done. An advisory lock is considered safe as no runway process can lock up any file forcefully. An advisory lock is considered safe as no runway process can lock up any file forcefully. It can read or write after a fixed number of failed attempts to lock the file. It can read or write after the fixed number of failed attempts to lock the file. Drawback is the program which create a process to share files must follow the above locking procedure to be cooperative. FCNTL file locking. FCNTL int f descriptor int cmd flag. Okay. CMD flag use. F set lk sets a file lock. Do not block if this cannot succeed immediately. F set lkw sets a file lock and blocks the calling process until the lock is acquired. F get lk queries as to which process locked a specific region of file. For file locking, the third argument is struct flock typed variable. Struct flock short I type, short events, of t I start, of t I pen, PIDT, IPID. I type and events fields of lock. I type value use. F RDLCK sets a read lock on a specified region. F WRLCK sets a write lock on a specific region. F unLCK unlocks a specified region. Events value use. Seeker, the I start value is added to the current file pointer address. Seek setter, the I start value is added to byte 0 of a file. Seek end, the I start value is added to the end of the file. The ILEN specifies the size of the locked region beginning from start address defined by a IVENS and ISTART. If ILEN is 0, then the length of the locked is imposed on the maximum size and also as it extends. It cannot have a negative value. When a F control is called, the variable contains the region of the file locked and an ID of the process that owns the locked region. This returned via IPID field of the variable. Lock promotion and splitting. If process sets a read lock and then a write lock, the read lock is now covered by a write lock. This process is called lock promotion. If a process sets a read lock and then a write lock, then the read lock is now covered by a write lock. This process is called lock promotion. If a process unlocks any region in between the region where the lock existed, then that lock is split into two locks over the two remaining regions. Mandatory locks can be achieved by setting the following attributes of the file. Turn on the set GID flag of the file. Turn off the group execute right of the file. All file locks set by a process will be unlocked. Terminates. If a process locks a file and then creates a child process via for, the child process will not inherit the lock. The return value of FC until is 0 if it succeeds or -1 if it fails. So this is a program for locking, and then directory file APIs. Why do you need directory files? Uses. To aid users in organizing their files into some structure based on specific use of files. To aid users in organizing files into some structures. They are also used by the operating system to convert the file path and names to their inode number. To create mkdir, constant car star path name, mode t mode. The mode argument specifies the access permission for the owner, group and others to be assigned to the file. Difference between mkdir and mknode. Directory created by mknode API does not contain AND links. These links are accessible only after user explicitly creates them. Directory created by mknode API does not contain AND links, dot and double dot links. These links are accessible only after the user explicitly creates them. Directory created by mkdir has the dot and double dot links created in one atomic operation and it is ready to be used. One can create directories via a system APIs as well. Newly created directory has its user ID set to the effective user ID of the process that creates it. Directory group ID will be set to either the effective group ID of the calling process or the group ID of the parent directory that hosts the new directory. Functions. Open dir. Dir star open dir, constant car star path name. This opens the file or for read only. Read dir. Direct read dir star dir f descriptor. The dir f descriptor value is a dir star return value from an open dir call. Close dir. Int close dir star dir f descriptor. It terminates the connection between the dir f descriptor handler and a directory file. Rewind dir. Void rewind dir star dir f descriptor used to reset the file pointer associated with the dir f descriptor. RMDIR API. Int RMDIR constant car star path name. Used to remove the directory files. Users may also use the unlink API to remove directories provided they have super user privilege. These APIs require that the directories to be removed be empty, in that they contain no other than dot and double dot links. Device file APIs. Device files are used to interface physical devices with application programs. Device files may be character based or a block based. The only difference between device files and regular files are the ways in which device files are created and the fact that LSEC is not applicable for character device file. To create mk node, int mk node, constant char star path name, mode t mode, int device id. Device id is extra here, int device id. The mode argument specifies the access permission of the file. The device id contains the major and minor device numbers. The lowest byte of the device id is the set to minor device number, and the next byte is set to the major device number. The device id contains the major and minor device number. The lowest byte of the device id is set to minor device number, and next byte is set to major device number. Major and minor numbers. When a process reads from or writes to a device file, the file's major device number is used to locate and invoke a device driver function that does the actual data transmission. When a process reads from or writes to a device file, the file's major device number is used to locate and invoke a device driver function that does the actual data transmission. The minor device number is an argument being passed to a device driver function when it is invoked. The minor device number specifies the parameter to be used for particular device type. The minor device number specifies the parameters to be used for particular device type. A device may be removed via the unlink API. If ONoCTTY flag is set to open call, the kernel will not set the character device file opened as the controlling terminal in the absence of one. The ONonBlock flag specifies that open call and any subsequent read or write calls to a device file should be non-blocking to the process. The ONonBlock flag specifies that open call and any subsequent read or write calls to a device file should be non-blocking to a process. FIFO file APIs. These are special device files used for inter-process communication. These are also known as named files. Data written to FIFO file are stored in a fixed size buffer and rewritten in a first in first out order. To create int mkFIFO, constant char star path name, mode t mode. How synchronization is provided. When a process opens a FIFO file for read only, the kernel will block the process until there is another process that opens the same file for write. When a process opens the FIFO file for read only, the kernel will block the process until there is another process that opens the same file for write. If a process opens a FIFO for write, it will be blocked until another process opens the FIFO for read. This provides a method of process synchronization. If a process writes to a FIFO that is full, process will be blocked until another process has read data from FIFO to make room for the new data in a FIFO. If a process attempts to read data from FIFO that is empty, the process will be blocked until another process writes data to FIFO. If a process does not desire to be blocked by a FIFO, it can specify the ONonBlock flag in an open call to the FIFO file. Unix system file defines the ONDLA flag, which is similar to ONonBlock flag. In case of ONDLA flag, the read and write function will be written as 0 value when they are supposed to block a process. If a process writes to a FIFO file that has no other process attached to it for read, the kernel will send a SIGPipe signal to the process to notify it of the illegal operation. If two processes communicate via FIFO file, it is important that the writer process closes its file descriptor when it is done, so that the reader process can see the end of file condition. Pipe API, another method to create FIFO file for inter-process communication. Int pipe, int FDS2. Used of FDS arguments are FDS0 is a file descriptor to read data from FIFO file. FDS1 is a file descriptor to write a data to a FIFO file. The child process inherit FIFO file descriptor from the parent, and they can communicate among themselves and the parent via the FIFO file. Hard and symbolic links. Hard link in a unix is path name for a file. To create a hard link in a ln command is used. Symbolic link is also means of referencing a file. To create a symbolic link, ln command is used with option S. Difference cp and ln command. Cp command creates a duplicated copy of file to another file with a different path name, whereas an ln command saves a space by not duplicating the copy. Here the new file will have same inode number as the original file. Difference between hard link and symbolic link. Hard link does not create a new inode. Cannot link directories unless it is done by root. Can link directories. Cannot link files across file system. Can link files across file system. Increase hard link count of the linked inode. Does not change the hard link count of the linked inode. Increase hard link count of the linked inode. Does not change the hard link count of the linked inode. Symbolic link file APIs. They were developed to overcome the several shortcomings of hard links. Symbolic links can link from cross file system. Symbolic links can link directory files. Symbolic links always reference the latest version of the file to which they link. Hard links can be broken by removal of one or more links, but symbolic link will not be broken. Okay.